Imagine standing at the edge of a coastline that no longer exists. The water beneath your feet is calm, the air is cold, and somewhere behind you a forest stretches back toward mountains that are slowly, almost imperceptibly, beginning to weep. Not from rain, from ice. Ice that has held the world in its grip for tens of thousands of years, finally, reluctantly, letting go. That's the world at 11,600 years ago. And something happened there. Something enormous. Something that may have burned itself so deeply into human memory that echoes of it are still reverberating in the oldest stories ever written down. Tonight, we're going to follow that echo back to its source. Or at least we're going to try if you're using this to fall asleep. That's exactly what it's here for. So settle in, and before you drift off, drop a comment telling me where you are and what time it is. I genuinely read them, and there's something almost poetic about people from Berlin and Bangkok and Buenos Aires all lying in the dark at different hours, thinking about the same ancient world. Tell me where you are. I'd love to know now. The Ice Age. For most of human prehistory, the planet looked almost nothing like it does today. Sea levels were dramatically lower. Coastlines extended hundreds of miles further out into what are now open oceans. The English Channel didn't exist. The Persian Gulf was dry land. The continental shelf between Siberia and Alaska was a broad, grassy plain. The world had edges we've completely forgotten about. Shorelines where people walked and fished and built fires and buried their dead. Shorelines that are now sitting under 60, 100, sometimes 300 feet of water. And then the ice started melting. It didn't happen all at once. The transition out of the last ice age, what geologists call the end of the Pleistocene, and the beginning of the Holocene, played out over thousands of years. But there were moments within that long melt when things happened very fast. Faster than any single human lifetime could fully comprehend. But fast enough that a community living on a river delta or a coastal plain might experience catastrophic change within a generation. Within a decade, sometimes according to certain geological markers, within days. Around 11,600 years ago, one of those accelerations appears to have occurred. Global temperatures shifted sharply. Ice sheets that had been retreating slowly lurched forward into collapse. Meltwater that had been pooling behind natural dams of ice and sediment may have broken through in pulses so large they altered ocean salinity, disrupted Atlantic circulation, and raised sea levels by meters in spans of time that are, geologically speaking, almost instantaneous. And here's the question at the center of everything we're going to explore tonight. Did that transformation, that violent, world-reshaping surge of meltwater and rising seas, leave a mark on the people who witnessed it? Not just in the landscape, in the mind, in story, in myth. Because here is something genuinely remarkable. Across cultures separated by oceans and millennia, there exist flood traditions, great inundations, waters that covered the earth, survivors in boats on mountains, waiting for the waters to recede. The details differ, the gods and heroes change, the moral frameworks wrapped around the story shift depending on who's telling it. But the core image, a world drowned and remade, appears again and again in the oldest layers of human storytelling. Now, this doesn't prove anything. That's important to say right at the start. Floods are common, rivers overflow, monsoons devastate. Local disasters generate local legends, and legends travel. A story about a catastrophic flood in ancient Mesopotamia doesn't necessarily trace back to a single real event. It might be a composite. It might be entirely metaphorical. The archaeology doesn't always cooperate with the narrative we'd like to build, but it also doesn't fully close the door. Because some of the geological candidates for a genuinely catastrophic flooding event around this period are striking. There's the possibility of dramatic inundations around the Black Sea basin. There are the sudden drownings of vast lowland plains in what is now the North Sea, a place researchers have started calling Doggerland, a lost world of rivers and wetlands and human habitation, now sitting silently beneath grey water. There are meltwater pulses in North America of almost incomprehensible scale, glacial lakes the size of inland seas releasing their contents into the Atlantic in events that would have changed the face of the continent overnight. We're going to look at all of them. We're going to weigh the evidence carefully, because this is a topic where it's very easy to reach too far, to let the romance of the idea pull you past what the data actually supports. And we're going to be honest about where the certainty ends and the speculation begins, because that's where the real intellectual adventure lives. What we can say with confidence is this: the world changed profoundly around 11,600 years ago. People were living through that change. People with language, with memory, with the capacity to pass experience down through generations in the form of story. And something, whether a single catastrophic event or a long accumulating series of losses, coastline after coastline disappearing under rising seas, drove something deep into the human imagination that we are arguably still carrying today. Archaeology can show us some of it. Geology can show us more. Ancient texts can whisper at the edges of what both disciplines reach. And the honest answer, the genuinely fascinating answer, is that we don't fully know yet. We may never fully know, but the question itself is worth sitting with in the dark. So let's go back, all the way back to a world that was warming fast, where the ice was beginning to give way, and where the coastlines people had known for generations were slowly, then suddenly beginning to disappear. To understand what was lost, you first have to understand what was there. And what was there in the world before the water rose was something most of us have never been taught to picture. Not the sparse, difficult, barely surviving existence that we sometimes imagine when we think of prehistoric people. Something richer than that, something more connected, more populated, more geographically complex than almost any map you've ever seen, because the maps we grow up with are maps of a drowned world. They show us the coastlines that survived. They don't show us what's underneath. At the height of the last ice age, roughly 20,000 years ago, global sea levels were somewhere between 120 and 130 meters lower than they are today. That's not a small difference. That's a transformation. The continental shelves that now lie beneath shallow coastal seas were exposed land. Land with rivers and wetlands and forests and beaches and estuaries. Land where animals grazed and humans built fires and children grew up learning the names of places that no longer exist in any language spoken today. The world had an entirely different shape, different edges, different interiors. By 11,600 years ago, a good portion of that ice had already melted. Sea levels had been rising for thousands of years. But they still hadn't reached where they are now. In many parts of the world, the coastline still extended significantly further out than it does today. The British Isles were not islands, they were a peninsula connected to the European continent across a broad, low-lying plain that geographers and archaeologists have started calling Doggerland, a name we'll come back to in depth. The Persian Gulf was a river valley. Southeast Asia's islands were a continuous landmass, sometimes called Sunderland. The coast of what is now India extended much further into the Indian Ocean. The coastline of North America had a different face entirely. These weren't just geographical curiosities, they were home. And here's what makes this period so vivid, so human, so worth thinking about. The people living in this landscape were not primitive in any meaningful sense. They were Homo sapiens, fully modern in every cognitive and biological dimension. They were us, navigating a different world. They made complex tools from stone and bone and wood. They tracked animal migrations across hundreds of miles and planned their movements accordingly. They knew the sky well enough to navigate by it. They sang, almost certainly. They had names for everything around them. They remembered, and they told stories about what they remembered, and those stories were passed to their children, who passed them further. These were mobile foragers, which sounds simple until you understand what that actually involved. Think less wandering and more managed rotation. Groups of perhaps 20 to 50 people moving through known landscapes along routes, refined over generations, visiting certain river crossings in spring when fish were running, certain upland areas in summer for plant foods, certain coastal zones when the weather turned and the shellfish beds were accessible. Seasonal camps that may have been returned to year after year until they began to look less like temporary stops and more like places with history, with meaning, with something you might almost call belonging, and coastlines specifically were critical. There's a reason human populations appear to have tracked coastlines throughout prehistory with something approaching devotion. The coast offers a kind of ecological abundance that inland environments rarely match. You have marine resources, fish, shellfish, sea mammals, seabirds, the rich pickings of the intertidal zone alongside whatever the adjacent land provides. Calories from the sea are dense and reliable, in a way that hunting alone rarely is. Shellfish especially are something close to a miracle food for a foraging society. They don't run away, they don't require stalking across miles of terrain. You can harvest them at low tide and carry them back to camp and feed your children with a degree of consistency that reduces the anxiety, the constant background pressure of wondering whether you'll find enough today. Coastal zones also served as natural highways. Water is easier to travel along than through, and coastal routes allowed groups to move significant distances while staying close to that reliable food supply. There's growing evidence that early human migrations followed coastlines, that the route out of Africa into South Asia, and eventually Australia, may have traced the Indian Ocean shore rather than pushing through difficult inland terrain. The coast wasn't just a food source, it was a corridor, a way of moving through the world without losing the thread of the resources that kept you alive. All of this means that the populations living along those now submerged coastal shelves may have been among the densest and most culturally complex in the world at the time. Not in cities, not in any way that looks like what came later, but denser than the inland groups, more sedentary in their habits, with more leisure time than people often imagine for pre-agricultural societies. Because when food is reliable, you have time for other things. For craft, for ceremony, for the long, slow accumulation of knowledge and story that eventually becomes tradition, and almost none of it is accessible to us now. This is the part that tends to stop archaeologists cold when they sit with it long enough. The most densely populated, most resource-rich, most culturally active zones of the late Pleistocene world are now sitting underwater. The sites are there. We know they're there. Occasionally, dredging operations or fishing nets pull up worked flint from the bottom of the North Sea, or mammoth bones, or fragments of wood that have no business being where they are unless the sea floor was once above water. In 2019, researchers off the coast of Florida found submerged archaeological sites containing stone tools and the bones of extinct animals, clearly evidence of human habitation on land now 15 feet underwater. This is happening in multiple places, across multiple oceans, wherever the geometry of the ancient coastline puts it within diving or survey range. The archaeology of the Ice Age, in other words, is systematically biased toward inland sites, toward caves and upland camps and river terraces above the floodline, simply because those are the places that remained dry. The richest zones of human activity may be the least recoverable. We've built most of our picture of prehistoric life from the parts of the past that happen to have survived sea level rise. That's not nothing, but it's a very specific slice, and recognizing that should make us a little humble about everything we think we know. Now think about what happens when that world, those specific coastlines, those known river mouths and shellfish beds and seasonal camps, when all of that begins to flood. If the process is slow enough, maybe it doesn't feel like catastrophe. Maybe it feels like weather, like variation, like the kind of slow environmental shift that human communities adapt to generation by generation without any single generation experiencing it as a crisis. Sea levels rising a few millimeters per year. Year after year, the shore retreating so gradually that you only notice it in the way old people talk about places that used to be further out. That kind of change is manageable. People move. People adjust. The knowledge shifts and the stories shift with it. But if it's fast, if the water rises in a pulse rather than a drift, if a shoreline that a community has lived on for generations disappears not over centuries but over decades or years, or in some extreme scenarios over days and weeks, that's a different kind of experience entirely. That's the kind of event that leaves marks. On landscape, yes, but also on the psyche, on the deep grammar of how a people understand the world and their place in it. A rapid flood doesn't just destroy settlements, it erases landmarks. It takes the names out of the geography. It drowns the graves of your ancestors and the paths you knew and the places where certain things always happened at certain times of year. For societies whose entire body of knowledge was encoded not in books or databases, but in landscape, in the named places of a known world, that kind of loss is not just physical. It's epistemological. It's a rupture in the continuity of knowing where you are and who you are in relation to the land. And that kind of rupture, if it was sharp enough, dramatic enough, collective enough in its scale, might be exactly the kind of thing that gets wrapped in story and carried forward. Not as a historical record in any formal sense, but as a felt truth, a foundational wound, a memory of before that gets retold and embellished and mythologized over generations until it becomes something that looks, to later scholars sitting in well-lit libraries, like folklore. The question is whether anything like that actually happened, whether the geological record contains evidence of a flooding event dramatic enough to have registered in exactly this way. And the answer, as it turns out, is complicated and genuinely fascinating, because the planet around 11,600 years ago was doing some extraordinary things. The climate was shifting, the ice was moving, and the water was going somewhere. To see what the water might have done, you have to understand what the climate was doing. About 12,900 years ago, just when the world seemed to be on a gentle path out of the last ice age, it snapped back. Almost literally snapped in geological terms. Temperatures in many parts of the northern hemisphere plunged again. Ice sheets stabilized or even advanced locally, and conditions that had been slowly softening turned harsh and cold. Climatologists call this interval the Younger Dryas. On a graph, it looks wrong. Instead of a smooth climb from glacial cold to interglacial warmth, you get this sharp downward spike, a sawtooth in the record. In Greenland ice cores, the shift into the Younger Dryas shows up as an abrupt drop in temperature proxies, something that may have unfolded over as little as a decade or two. Not centuries, years, within the memory of a single human lifetime. Why it happened is still debated. One idea centers on meltwater. As the big ice sheets of North America decayed, they fed enormous glacial lakes. If one of those lakes released a sudden flood of fresh water into the North Atlantic, it could have disrupted the great conveyor belt circulation of the oceans that moves heat around the planet, shut down or weaken that current, and the North Atlantic region cools dramatically. Other researchers have suggested additional triggers, shifting wind belts, changing sea ice, even a controversial hypothesis involving extraterrestrial impacts and widespread fires. No single explanation commands unanimous agreement, and it's possible that more than one process was involved, stacking effects in a system already on the edge. Whatever the cause, for people on the ground, it wouldn't have been a neat scientific label. It would have been weather that went wrong and stayed wrong. In some regions, winters lengthened and deepened. Growing seasons shrank. Plants that had begun to recolonize open ground after the height of the Ice Age stalled or retreated. In the pollen grains trapped in lake sediments, you can see forests giving way again to cold-tolerant shrubs and grasses. Animals followed the plants as they had always done, and humans followed the animals because that is what humans had to do. But it didn't look the same everywhere. The Younger Dryas is clearest in the North Atlantic world, because that's where we have the best high-resolution records and where the ocean circulation changes would have hit hardest. Farther south, farther inland, in different ocean basins, the signal blurs and frays. Some places cooled sharply. Some shifted toward dryness, more than cold. Others, especially in the tropics, felt the changes more in where and when the rains came than in absolute temperature. Because that's the quieter part of this story, not just how warm or cold it was, but where the water fell. Climate is never just about temperature. It's about the choreography of air and ocean, the invisible corridors along which moisture moves, condenses, and finally comes down as rain or snow. When the North Atlantic cools rapidly, the positions of the jet streams, the storm tracks, and the great belts of tropical rain all begin to wobble. Monsoons weaken or shift in timing. Storms that once curved along one path bend toward another. Lake levels in some parts of the world during the Younger Dryas fell dramatically, a sign of reduced rainfall and greater evaporation. In other regions, lakes swelled, fed by new storm tracks and heavier snows in the mountains. Some rivers diminished to trickles, others became volatile, surging with floods when rare storms did arrive. For human communities whose food came directly from local plants, animals, and fish, this mattered more than a thermometer reading. A herd route that had been predictably used every spring might be abandoned as grazing deteriorated. A marsh that had been full of birds and tubers could dry out in a generation. A river mouth rich in fish might suddenly silt up or shift its channel after a single violent flood season. The Younger Dryas lasted more than 1,000 years, long enough for multiple generations to know only its realities. For a child born into the middle of it, stories of slightly warmer, gentler conditions a few centuries earlier might already have felt like legend. The edge of the ice on the horizon, the particular ways the north wind carried snow, the months when nothing much grew, those would have been the constants of their world. And then, just as abruptly as it began, it ended. Around 11,700 years ago, the climate system flipped again. In ice core records, the line climbs as sharply as it once fell. Temperatures in Greenland jump by several degrees in what may again have been only decades. This transition marks the beginning of the Holocene, the relatively stable warm period we're still living in now. With that rapid warming, all the connected systems began to reorganize. Glaciers thinned and retreated. Permafrost began to thaw. Vegetation belts marched poleward and up mountain slopes. In places that had endured long, dry, cold wetlands reappeared. Forests that had been hanging on in sheltered pockets started to spread. Grasses suitable for large grazing herds expanded into new ranges. Rainfall patterns shifted once more. The African monsoon strengthened and pushed farther north than it does today, turning what are now hyper-arid regions of the Sahara into a patchwork of lakes, rivers, and grasslands. In the eastern Mediterranean, lake sediments suggest changing balances between wet and dry years. In parts of Asia, the great monsoon systems reorganized, feeding some basins while starving others. In the Americas, glaciers withdrew from valley mouths and new proglacial lakes formed, their outflows unpredictable and sometimes catastrophic. For people whose lives were tightly tied to seasonal rounds, this second flip would have felt like the world loosening. In some areas, game became more abundant. Plant foods that had been rare or marginal turned into staples. Rivers ran more consistently, or at least in new, learnable ways. In other places, though, the change may have meant the opposite. A formerly productive cold steppe turning to forest could make life harder for specialized big game hunters. A favored wintering ground might become boggy or flood-prone. A low-lying crossing place on a river might become impassable in the new spring melt. Abrupt change, even when it moves in the direction of greater overall warmth and productivity, is still stress. It compresses the time available for cultural adaptation. Instead of having many generations to gently adjust when the rains come, or which valley holds snow the longest, you might have only a few. Routes that had been used for centuries might suddenly become dangerous or pointless. The old knowledge of when to move and where doesn't map cleanly onto the new world. Under those conditions, some groups likely chose to stay and adapt in place, altering their toolkits, their diets, their seasonal calendars. Others moved, not as one great migration, but as countless small decisions: to follow the herds a bit farther north this year, to settle a little higher on the slope, to try fishing in that newly formed lake that didn't exist when your grandparents were born. Over time, these small shifts add up to large-scale repatterning of where people live and how they use the land. And again, it's important to say, this wasn't uniform. There is no single Younger Dryas story, no single Holocene dawn. Each valley, each coastline, each river corridor had its own sequence of drying, flooding, freezing, thawing. Archaeologists and paleoclimatologists can sketch regional patterns, but the lived reality would have been highly local. One community's catastrophe might have been another's opening. What unites these experiences is not their precise timing or severity, but their abruptness. The feeling that the old world was slipping out from under people's feet on a timescale they could actually perceive. The sense that the seasons themselves had become unreliable. Into this already unstable canvas, you can now start to place rising seas, meltwater pulses, and the specific floods that may have cut into those ancient coastlines. Because as the climate flipped into the early Holocene and the ice began to give way in earnest, the oceans started to answer. When people imagine an ancient flood, they tend to picture a single storm. Rain that doesn't stop, rivers jumping their banks, a wall of water sweeping through a valley and then, eventually, draining away. The real flood that reshaped the world after the last ice age was slower, deeper, and more patient. Its reservoir was not a cloud bank, but the ice sheets themselves. At the peak of the last glaciation, enormous slabs of ice sat on top of the continents. In North America, the Laurentide ice sheet sprawled from what is now the American Midwest to the Arctic Ocean. In northern Europe and western Russia, another complex of ice, sometimes called the Fennoscandian ice sheet, buried whole regions under kilometers of frozen water. On Greenland, in mountain ranges from the Rockies to the Alps, and in parts of Antarctica, glaciers locked up water that today would flow as ocean. Think of all that ice as sea level, temporarily stored on land. When the climate warmed and the ice began to melt, that stored water had to go somewhere. It went back to the oceans over thousands of years. Global sea level rose by more than 100 meters. Not centimeters, not a few meters, a height change larger than most modern skyscrapers. On a global average, this rise was gradual. If you spread out the entire post-Ice Age increase, you get something like a few millimeters per year, give or take, depending on the interval, measured against the entire history of the planet. That pace is not especially remarkable. Measured against a human life, it is. Imagine a child born in a small coastal camp. By the time that child is old, the place where they learned to swim as a teenager might be a shallow bay. A sandbar that was useful for trapping fish might now be a channel deep enough for seals. The burial mounds on the low ground near the shore might flood at the highest tides, forcing people to move their dead. Multiply that by a few generations, and low-lying ground that seemed permanent starts to dissolve into water. Even without any dramatic events, the line between land and sea becomes mobile. But the rise was not perfectly smooth. Ice sheets do not melt like ice cubes in a glass. They crack, surge, stagnate, and sometimes break catastrophically. When a large section of an ice sheet collapses, or when a glacial lake finds a new outlet, the flow of meltwater to the oceans can jump, at least for a while. Geologists call the fastest of these intervals meltwater pulses, shorter episodes superimposed on the long climb of sea level when the oceans seem to leap instead of step. One of the most discussed is an event around 14,500 years ago, sometimes labelled Meltwater Pulse 1A. In certain coral reef records, it looks like sea level may have risen by more than 10 metres in just a few centuries. Not everywhere agrees. Different markers give different numbers, and the precise timing, magnitude and sources of that water are still argued about. Some researchers see one big pulse, others see several smaller steps. Some argue for a dominant North American source. Others include contributions from the Antarctic ice sheet. What matters for our story is not the exact curve on a graph, but the principle. At times, sea level did not just creep higher, it surged. Not like a tsunami, hours or days, but like a relentless sequence of king tides stacked over the span of a human life. Shorelines that had been stable for centuries could start to retreat rapidly on the scale of villages, fields and sacred places. Even without meltwater pulses, the experience of sea level rise was never evenly distributed. The solid earth flexes under the weight of ice. Where a kilometre-thick ice sheet once pushed the crust downward, that crust has been slowly rebounding since the melt. In some formerly glaciated regions, the land has been rising faster than the oceans, and old shorelines now sit high above modern sea level. In other places, far from the old ice, but within reach of its gravitational pull, the opposite happened. As the ice shrank, those regions effectively lost part of the upward tug that had been holding water toward the ice sheets, and their local seas rose more than the global average. To a person living in a coastal lowland, none of this would have been expressed as isostatic adjustment or gravitational potential. It would have been an impression that the water was gaining. Certain environments are especially vulnerable. River deltas, where great rivers, slow and spread out into many channels, build their land from mud and sand, grain by grain. Estuaries, where freshwater and saltwater mingle, depend on a delicate balance between river flow, tides and sediments. Coastal plains that barely rise above high tide exist as long as the sea does not press too hard. As sea level rises, these places are the first to drown. The front edge of a delta retreats inland. Channels widen and deepen. Marshes that once flooded only in storms begin to flood with every ordinary tide. Trees die as salt wedges creep upstream. Islands that once offered safe camps during seasonal fishing runs erode away. The river mouth the ancestors used is now somewhere out under the waves. Archaeologists see this in the way so many of the most promising late Ice Age and early Holocene sites are missing along modern coasts. We know people were there, because inland sites show their tools and their movements. We find shell-middens heaps of discarded mollusk shells and fish bones, perched above ancient shorelines that are now far from the sea. But we also know that the most attractive ground for early communities would have been close to the rich interface of fresh and salt water, where fish, birds and plants concentrate. Much of that ancient coastline is now a drowned world, tens of meters below present sea level, buried under mud. Whatever stories those camps and villages could have told are resting with the submerged river channels and the stumps of long-dead forests. For the people who once lived there, the encroaching sea would not have been an abstract geological process. It would have felt like a kind of siege. You can picture it across generations. Grandparents speaking of a wide meadow where children played, now a tidal flat. Parents warning their own children not to camp too low, because the water comes farther each year. Maybe an elder insisting that a particular line of stones marks where the sea used to stop. The memory carried like a quiet accusation against the restless tide. Add to this the occasional shock, a storm that coincides with the highest tides of the year, driving waves far inland along a coastline already weakened by higher sea level. A barrier beach overtopped and cut through, turning one protected lagoon into an open bay in a single season. A freshwater lake at the river mouth abruptly shifting to brackish, killing familiar plants, changing the fish. Under those conditions, it would not be hard to feel that the world was being taken by water, not as one single apocalyptic event, but as a series of encroachments. Each generation pushing its camps, its fields, its temples or shrines a little farther uphill. Each generation inheriting stories of lost land. On a map drawn over thousands of years, coastlines would appear to retreat like a slow-motion tide. Low plains that once connected islands to the mainland vanish. The mouths of rivers move inland. Narrow straits widen into seas. On the ground, for the people actually living through it, this could become the seed of a flood world imagination. A sense that there was once more land, that the ancestors had walked where now only fish can swim. That the boundary between dry ground and ocean is not a fixed line, but a moving front. Later, when communities began to settle more permanently in some of these marginal zones, building habits, rituals and identities around specific pieces of land, the loss of those places would have cut even deeper. A flood was no longer just the river overstepping for a season. It was the sea taking something and never giving it back. From that perspective, the next part of the story becomes easier to understand, because those rising seas did not only nibble politely at the edges. They interacted with the great glacial lakes and the changing rivers in ways that sometimes produced sudden, violent outbursts of water, the kind of events that could, in a human mind, fuse a long, creeping inundation into the memory of a single, unforgettable flood. To understand those outbursts, it helps to start with something deceptively simple: a lake. A glacial lake is, at heart, just water trapped by ice or by the rubble that ice leaves behind. As glaciers move, they grind the underlying rock into a mixture of boulders, gravel, sand, and fine powder. When the ice front stalls or retreats, that debris can pile up into ridges called moraines. Sometimes those moraines form natural dams across valleys. Meltwater streams pool behind them, filling basins that did not exist before the ice. Other lakes form directly against the ice itself. Imagine a wall of glacier blocking a valley, meltwater running off the surface and from beneath the ice has nowhere to go, so it gathers in front of the ice wall, held back like water against a dam. These ice-dammed lakes can grow quietly year after year, as long as the dam holds. The key point is that these dams are not engineered structures. They are not concrete. They are piles of loose rock and mud, or frozen water, or some combination of both. They can look solid, especially to people who have lived beside them for generations. But they are vulnerable in ways that are not always obvious until they fail. Failure can start small: a warm summer, a heavy rain, a crack opening deep within the ice. Water is patient. It seeps into joints, finds weak layers in the moraine, carves tiny channels. Every bit of flow erodes more material, widening the passage. At first, the lake level drops slowly. Then the race between erosion and resistance tips, and the system crosses a threshold. What had been a trickle becomes a torrent. The outlet channel incises downward. The effective spillway drops, and suddenly the entire volume of the lake has access to a lower escape route. Within hours or days, billions of tons of water can pour through a gap that did not exist a week before. Geologists call this a glacial lake outburst flood. In the literature you'll see terms like jökulhlaup, borrowed from Icelandic. To the people downstream there would have been no technical word. There would have been only the arrival of water where water had no business being, moving with a strength that made ordinary floods seem like nothing. The energy involved in these events is hard to exaggerate. When a deep lake drains rapidly, the flow at the breach can rival the largest rivers on Earth, but concentrated into a much narrower corridor. The water is not clean. It is thick with sand, gravel and boulders ripped from the failing dam and the valley floor. This slurry behaves like liquid sandpaper. able to pluck blocks of rock the size of houses out of bedrock and carry them downstream. Afterward, when the water finally calms, it leaves behind landscapes that do not look like the work of ordinary rivers. In parts of eastern Washington state, there are broad, stripped bedrock surfaces known as scablands. Instead of gentle floodplains, you see channels carved hundreds of feet deep into the basalt, dry waterfalls taller than skyscrapers, and fields swept almost bare of soil. For decades, geologists argued about how such features could form. Today, many accept that they were cut by catastrophic outburst floods from a glacial lake once dammed by the edge of the North American ice sheet. On some ancient flood surfaces you find giant ripple marks, undulating ridges of gravel and sand, each one as high as a house and spaced like waves frozen in stone. Normal stream ripples are tiny, centimetres between crests. To build ripples tens of metres apart, you need water flowing fast and deep at scales that only an outburst flood can provide. Scattered across landscapes shaped by Ice Age floods, you also find erratics, solitary boulders of rock that do not match the bedrock beneath them. Some travelled on or within the ice itself, dropped as glaciers melted. Others were rolled and shoved by the floodwaters, stranded high on hillsides or in fields where they seem absurdly out of place. To people walking those lands without any concept of glaciers, such stones must have looked like visitors from somewhere else, delivered by forces beyond ordinary experience. Farther out, where the flood emerges from its confining valley and spills onto open lowlands, it can spread into great fans of sediment. These megafans are vast, cone-shaped aprons of gravel and sand crossed by branching channels. They testify to water that burst from a narrow throat and then lost its focus, fanning out, dropping its load as it slowed. All of this is the signature of sudden catastrophe on a regional scale. A single lake can drain and rework hundreds of kilometres of river system, reroute channels, drown valleys, and strip away the soil that plants, animals, and people depend on. Campsites vanish. Hunting grounds are transformed into bare rock and boulder fields. Paths that linked one group to another are cut by new chasms or redirected rivers. But even a truly enormous outburst flood does not raise the entire global ocean overnight. When you pour water into a basin the size of all the world's seas, the effect of a single event is spread thin. A glacial lake might hold the equivalent of a few centimetres of global sea level, maybe a bit more. Released all at once, that water could cause a local surge where it enters the ocean, raising tides or changing currents along a particular coast for a time. Over months to years, though, it would blend into the larger system. The lasting mark on global sea level would be a small step, a fraction of the overall rise driven by the long-term melting of the ice sheets. So there are two scales at work for people living along the path of an outburst flood. The experience could be apocalyptic, walls of water, roaring currents filled with trees and animals and debris, familiar landmarks gone in a day. For people living far away on a quiet shoreline, the same event might register only as a slightly higher tide next season, or not at all. Yet human memory does not naturally track scales the way geology does. If your community lives in a region where glaciers wax and wane over many generations, you might experience more than one such event. A lake drains catastrophically. Centuries later, as the ice advances or retreats again, another lake forms in a different valley, and it too eventually fails. In other parts of the world, similar lakes do the same, at different times. Each flood is local, but the stories about them can travel. Imagine traders, wanderers, marriage partners carrying tales of a river that turned to a monster overnight, of boulders moved by water, of valleys scoured clean. Another group far away has its own story, a mountain lake that vanished in a single day, a plain that became a channel, fields buried under gravel. Over long stretches of time, as people move, mix and retell, those separate memories can begin to merge. Add to this the background of slow sea level rise, of coasts creeping inland, of deltas drowning. When later generations look back, they are not seeing a neat chart of distinct processes. They inherit a bundle of impressions: water rising from below, water rushing from above, land disappearing under waves, lakes that burst, seas that do not retreat. Faced with that tangle, it is natural for oral traditions to compress. Many small floods, over many lifetimes, can be woven into the narrative of one great flood. The slow soaking of coastlines and the sudden violence of glacial lake outbursts confuse into a single idea. Once, the world was drier and wider, and then, in an age of wrath or sorrow, the waters came and took it away. Later, when we turn to specific regions, the Black Sea, the shallow plains of the North Sea, the Great Basins of North America, we will see how these mechanisms might have played out in particular human landscapes. But first, it is enough to keep one image in mind: ice holding back vast inland seas, and the knowledge that sometimes, without much warning, those frozen dams let go. If you follow the map east, away from the Atlantic and the drowned plains of the North Sea, you come to another basin that has drawn more than its share of attention: the Black Sea. Today it is a deep, almost landlocked inland sea, linked to the Mediterranean only by a narrow chain of straits. At its southwestern corner lies the Bosporus, a crooked blue scar cut through the bedrock between Europe and Asia, barely a kilometre wide in places. To a modern eye, it looks permanent, inevitable, like a river valley that has always been there. But in the late 1990s, a provocative idea began to circulate among geologists and oceanographers. What if, at the end of the Ice Age, the Black Sea basin was not a salty sea at all, but a large freshwater lake with a surface far below that of the rising Mediterranean? And what if, at some point, the Mediterranean climbed high enough to spill over a bedrock sill at the Bosporus and pour into that lower basin in a sudden, catastrophic rush? This is the core of the Black Sea flooding hypothesis. Picture the global oceans rising as the great ice sheets melt. The Mediterranean, fed by that global ocean, slowly fills and expands. To its northeast, the Black Sea basin sits like a separate bowl on a slightly lower shelf, connected to the Mediterranean only by a shallow threshold, an underwater ridge or bedrock lip beneath where Istanbul stands today. As long as the Mediterranean surface stays below that lip, the Black Sea basin remains cut off. Rivers from the north and west fill it with fresh water. Its outlet, if it has one, may be a smaller channel flowing the other way, from the Black Sea out toward the lower Mediterranean. People might live on broad, fertile plains around its margins, farming or foraging along stable shorelines. But the threshold is not high. As the Mediterranean rises, seasonal variations, storms, or small crustal adjustments could bring its water ever closer to the critical height. Then, at some moment, the balance tips. The sea level reaches the sill. Water begins to spill over. At first, it might be a trickle, like the beginning of a glacial lake outburst. But the same feedbacks apply. Once water starts to flow across a lip into a deeper basin, erosion gets to work. The channel incisors, deepens and widens. The sill lowers. More water pours through. Depending on the geometry of the basin and the height difference between the Mediterranean and the Black Sea lake, the resulting inflow could be enormous. In the most dramatic versions of the hypothesis, the inflow through the Bosporus becomes a roaring cataract, perhaps dozens of times greater than the flow of Niagara, running not for minutes but for months or years. The surface of the Black Sea rises rapidly, meters in a year perhaps, flooding low-lying shorelines at a pace far beyond normal coastal change. Villages, fields, burial grounds could be drowned within the span of a human life. To people on those shores, the sea itself would seem to be climbing uphill, swallowing the land without retreat. Supporters of this scenario point to several kinds of evidence. One line comes from submerged shorelines and terraces mapped on the Black Sea floor. Sonar surveys have revealed step-like features that look like old beach lines now far below the modern surface. Some appear to cluster at depths, suggesting a former lake standing significantly lower than today, followed by a rapid rise. Another line of evidence lies in the sediments themselves. Cores taken from the Black Sea floor show a sequence, older layers with characteristics of freshwater environments, certain minerals, organic matter and microfossils, topped abruptly by layers containing marine species and mud typical of saltier, oxygen-poor deep water. If the transition from freshwater lake to marine basin was sudden, you would expect to see a relatively sharp boundary between these two regimes. Shells add more detail. Freshwater mollusk shells in older layers give way to marine shells in newer ones. In some cores there appears to be a narrow interval where brackish conditions prevailed, suggesting a period when salt water first intruded and mixed with lake water before full marine conditions established. Radiocarbon dating of these shells has been used to estimate when the change occurred, often landing somewhere around 8,000 to 9,000 years ago. Chemistry offers another clue. The composition of the shells, the ratios of oxygen and carbon isotopes, can reflect the salinity and temperature of the water in which the organisms lived. Shifts in those ratios across the freshwater marine boundary hint at a relatively abrupt increase in salinity, consistent with a large influx of seawater rather than slow evaporation or minor climatic changes. Taken together, these strands create a tempting picture. A low-lying, freshwater Black Sea lake suddenly invaded by Mediterranean waters as global sea level rose, its shores drowned in a geologically brief interval, its ecology transformed. But as with many striking ideas in geology, the details have been fiercely debated. Some researchers argue that the supposed old shorelines on the Black Sea floor may be misinterpreted, or that they formed over longer intervals than the catastrophic model suggests. Others point out that radiocarbon dates from different cores and different parts of the basin do not always agree neatly, leaving room for a more gradual transition stretched over centuries rather than years or decades. There is also the question of direction. In some reconstructions, for at least part of the early Holocene, the Black Sea may have actually stood higher than the Mediterranean, draining outward through the Bosporus instead of being filled from the sea. In that case, the eventual reversal of flow might still have been important, but not necessarily a single Niagara-like onrush. Alternative interpretations see the change from freshwater to marine conditions as a multi-step process. Perhaps initial moderate inflows started earlier, with the salinity creeping upward over generations. The apparent sharpness of the transition in some cores might partly reflect how sediments accumulate in deep basins, compressing time in ways that make drawn-out processes look more sudden in the record. Even among those who accept a significant marine transgression into the Black Sea, there is disagreement about its impact on human communities. Were there dense farming villages around the ancient lake's margins, or more scattered groups of foragers and early cultivators? How far and how fast did the shoreline move in the places people actually lived? The answers matter for deciding whether the event would feel like a slow, unwelcome change or something closer to a catastrophe. Yet, whether the Black Sea flooding was explosive or drawn out, the idea resonates strongly with later flood traditions from the Near East. Think of the core elements those stories share. A world that was once more spacious, where people lived on land that now lies beneath the water, a sudden rising of the sea, or a breaching of barriers that once held back the deep, a great body of water invading a lower-lying region, unstoppable, indifferent, permanent. The Black Sea scenario, in its most dramatic form, offers exactly that imagery. Communities along the northern coasts of Anatolia, the Caucasus or the Western Steppe, if they were present in sufficient numbers, would have watched as a familiar horizon altered. Forests or meadows near the shore could have been lost, bays deepened, headlands turned to islands. For people whose myths already featured primordial floods or chaotic waters suppressed by gods, a real-world event of this kind could provide fresh detail, a tangible example, a place name to attach to an older cosmic motif. Even if the physical flooding unfolded over several lifetimes, the way stories compress time could turn a long retreat into a single remembered moment in the days of our ancestors, when the sea broke through the gates and came rushing in. Later, as populations shifted south and east, as languages changed and writing appeared in Mesopotamia, those memories might be reshaped, merged with other tales of rising rivers and overflowing lakes. The geography could blur. The Great Water might no longer be the Black Sea at all, but an archetypal flood in which the boundaries between river, lake, and ocean dissolve. So when modern researchers look at tablets from the ancient Near East, describing a god who decides to send a deluge, a chosen survivor warned to build a boat, a landscape scrubbed clean and then repopulated, they sometimes see, faintly behind the cuneiform signs, the silhouette of real coastlines and drowned shores. The Black Sea flooding hypothesis is one way of linking that silhouette to a specific place and time. Whether that link is precise or only poetic is still an open question. But it reminds us that behind the myth of a single perfect flood, there may lie many separate waters, lakes that burst, seas that crept, and perhaps in a narrow strait between continents, a threshold that finally gave way. If you turn your attention back to the northwest, away from the Black Sea and its contested cataract, another drowned world waits beneath shallower, colder waters. Between modern Britain and continental Europe, there is now a broad expanse of grey-green sea, busy with shipping lanes and wind farms. But for most of the last ice age, that sea floor was dry land, a low rolling plain of rivers, marshes and forests, stretching from what is now eastern England to the coasts of Denmark, Germany and the Netherlands. Archaeologists call it Doggerland, after the Doggerbank, a sandbank where fishermen still haul up bones and tools from a landscape that no longer exists. At the height of the last glacial maximum, sea level stood more than 100 metres lower than today. The North Sea basin was mostly exposed. Broad river systems, including ancient extensions of the Thames, Rhine and other European rivers, braided together across the plain and flowed north toward what is now the Norwegian Sea. Herds of mammoth and reindeer grazed in the open steppe. Later, as the ice sheets began to retreat and the climate warmed, that steppe shifted. Grasses gave way in places to shrub and birch, then to mixed woodland. Low hills, river terraces, seasonal wetlands. By around 10,000 years ago, much of Doggerland probably looked like a kind of northern parkland. It was not empty. We do not have towns or stone monuments preserved out there. Waves and currents have scattered the evidence. But trawlers bring up worked flint tools, animal bones bearing cut marks, fragments of antler and bone points. Seismic surveys used by oil companies reveal buried river channels and ancient coastlines, the ghostly geometry of a living landscape. Pollen grains and plant remains from cores taken in the basin sketch in the vegetation. Together, these hints suggest that Mesolithic hunter-fisher-gatherers moved through Doggerland, camped along its rivers and lakes, fished its shallows, hunted its game, and gathered its plants. To them it was not some exotic lost world, it was home. A broad, continuous land bridge where you could, in principle, walk from what is now Yorkshire to Jutland without ever seeing the open ocean. Britain was not an island. It was simply the western edge of a larger northern plain. But this plain was doomed as the great ice sheets melted, global sea level rose. Not in a single surge, but in pulses, stair-steps separated by calmer periods. In the North Sea basin that meant water creeping back in, first along the lowest channels, then across the wider depressions. Marshes expanded where dry ground had been. Rivers backed up. Lakes grew brackish. Places that had been seasonal wetlands became permanent bogs. then shallow estuaries. From the perspective of geology, the drowning of Doggerland was relatively quick, several thousand years from high, dry plain to scattered islands. From the perspective of a family living there, it was slow-motion catastrophe. Your grandparents might have told stories of hunting grounds out beyond the new reed beds, places where the elders once walked to stalk red deer or follow reindeer migrations, now too wet, too boggy, not worth the trouble. Your parents might remember when a favourite camp on a river bend became impossible to reach, except by wading. You, in turn, would see the shoreline pull steadily inland, year after year, the horizon of dry land shrinking. Every generation would lose something: a crossing ford that became too deep, a meadow that turned to marsh, a burial place now rhythmically washed by the tide. People adapted, of course. They shifted campsites, learned new fishing spots, followed the retreating edges of habitable ground. But over time, Doggerland fragmented. The highest ridges and banks became peninsulas, then islands. What had been a continuous world of paths and river routes became an archipelago. Finally, even those last refuges succumbed, leaving only banks and sandbars beneath the waves. Layered on top of this slow retreat, there may have been moments of acute shock. Around 8,200 years ago, a massive submarine landslide off the coast of Norway, the Storegga Slide, sent a tsunami sweeping across the North Atlantic margins. Sediment layers in coastal peat bogs around the North Sea and in Scottish sea locks show distinctive tsunami deposits. Sand pushed far inland, laid down abruptly over much older soils and plant remains. Models suggest that in some low-lying coastal areas, waves several meters high could have surged ashore. For people already living with a sea that would not stop advancing, such an event would have been terrifying. One thing to watch the water creep over decades, another to see it leap in a single day, racing into river valleys and over marshes, tearing up vegetation, drowning game, destroying campsites. Some of the last remaining low-lying parts of Doggerland may have been especially vulnerable. A region already thinned by slow drowning might have lost whole pockets of habitable land in a matter of hours. Archaeology cannot yet put names or faces to those who watched this happen. We see them only through their tools, the bones they left behind, the pollen that marks their fires and clearings. But paleoecology allows us to say something about their world. They lived in mixed woodlands of birch, pine, and later oak. They exploited rich estuaries where rivers met the encroaching sea. They moved seasonally, following fish runs and bird migrations, perhaps timing their journeys to the rhythms of tides and spawning. To such people, the landscape itself would have seemed alive, changeable, responsive, a familiar promontory that steadily narrowed, a lagoon that opened suddenly to the deeper sea, a sandbank that grew, then vanished, then reappeared in some altered form. These were not abstract sea-level curves, but concrete, remembered places. Over centuries, each loss could be folded into stories. At first, perhaps, these were practical tales, warnings about where it was now unsafe to camp, reminders that the water took that place, do not trust the ground there. But as generations passed, and more of the old plain lay under waves, those warnings could deepen into myth. Ancestors who went out with the land, houses beneath the sea, forests where fish now swim. A time when you could walk to the far shore, followed by a time when the sea cut us off. Later still, when Britain truly became an island and boat crossings replaced footpaths, those stories might be told from both sides of the water, each with its own variations. On one shore, people remembered the last high ridge disappearing. On the other, they spoke of distant relatives who had lived out there and never returned. Over hundreds, then thousands of years, as languages shifted and cultures changed, the specific geography would blur. What remained was the pattern: land once dry, now drowned. A world made smaller by an encroaching sea, When we encounter later European and Near Eastern traditions of lost lands and sunken realms, from vague memories of lands under the waves to more elaborate stories of islands swallowed by the ocean, Doggerland offers one possible route. Not a single sudden apocalypse, but a drawn-out series of retreats and shocks, compressed by memory into simpler narratives of before and after. Whether or not any specific legend can be traced back to those plains beneath the North Sea, the pattern fits a broader human habit. When coastlines move, when seas claim familiar paths and graves and hunting grounds, people notice. They talk. They teach their children that the world was once wider. And even when the last dry hill is gone, those stories can float, carried forward over the very waters that erase the land. If you follow that same rising water around the curve of the northern hemisphere, you end up on another continent where ice and meltwater were changing the map on an even more dramatic scale. Across what is now Canada and the northern United States, the Laurentide ice sheet sat like a continent-wide dam. In places it was more than 2 kilometres thick, a wall of ancient snow and compressed ice sloping down toward its melting edge. In front of that edge, wherever the ice retreated just enough to let water pool but not enough for it to run freely to the sea, enormous lakes formed. The largest of these is known as Lake Agassiz. On a modern map, it would have covered much of Manitoba, western Ontario, parts of Saskatchewan, and sprawled down into what is now Minnesota and the Dakotas. At various times it may have held more fresh water than all the lakes on Earth today combined. But Agassiz was not alone. Other proglacial lakes, Lake Ojibwe, Lake McConnell, and many smaller basins filled lowlands along the ice margin, collecting melt from the thawing sheet. You can picture them as temporary hearts of fresh water pressed up against a body of ice, their shorelines shifting as the glacier pulsed forward or pulled back. These weren't stable, permanent features like modern Great Lakes. They were reservoirs waiting for an outlet. As long as ice blocked their natural drainage routes, they stayed dammed. But when that ice weakened, or when water found a low spillway, things could change very quickly. Geologists have spent decades arguing over where exactly those changes happened. One possibility is that Lake Agassiz and its siblings sometimes drained south into the Mississippi system. In that scenario, tremendous floods would have poured down through what is now the Red River Valley, into the Minnesota River Basin, and then into the Mississippi proper. The modern river would be a faint echo of a much larger, more violent flow. Its valley widened and deepened by water volumes far beyond anything seen in recorded history. Lowlands along the route could have been repeatedly scoured, old meanders abandoned, new channels carved almost overnight on human timescales. Another route points east. At certain times, models and shoreline evidence suggest that Agassiz and adjoining lakes may have overtopped low divides and spilled toward Hudson Bay and the Labrador coast. In those episodes, the floodwater would have run beneath or around the ice, then out into the North Atlantic. That matters because pouring that much fresh water into salty ocean currents can, in theory, change their behaviour. Some researchers link particular drainage events to disruptions in the Atlantic's overturning circulation and to brief periods of regional cooling. Still, other reconstructions propose a more westerly escape, where water found paths through what are now the Mackenzie or other Arctic river systems, sending plumes of fresh water into the polar seas instead. Each route paints a different picture, different coastlines receiving the shock, different deltas and estuaries abruptly rearranged, different coastal ecosystems and human communities affected. The underlying question still debated is how these bursts of fresh water interacted with climate. Ice core records, marine sediments, and lake data hint at sudden cool snaps, like the Younger Dryas and the 8.2 thousand year event, interrupting the general warming trend after the last glacial maximum. Some scientists see a neat connection, a big drainage of Lake Agassiz and its neighbours into the North Atlantic, the surface waters freshening, the great conveyor belt circulation that moves heat northward slowing, and the climate of the North Atlantic region dipping colder for a few centuries. Others caution that the picture is not that tidy. The timing of drainage events and cooling episodes does not always line up perfectly in the records we have. Climate is influenced by many factors: shifts in ice sheets, volcanic eruptions, solar variability, and it may be that meltwater was one player among several, nudging an already unstable system rather than single-handedly flipping a switch. In the background, the giant ice sheets themselves were still shrinking, changing the height of continents, the paths of winds, and the reflectivity of whole regions. To trace what actually happened on the ground, geologists and geomorphologists learn to read the tracks that floodwater leaves behind. One sign is the channel itself. Catastrophic meltwater floods don't just make ordinary river valleys a little bigger, they carve out features on a different scale. In parts of the northern Great Plains, for example, there are broad, flat-floored troughs, sometimes called spillways, that look oversized for the modern streams trickling through them. Their banks may be lined with streamlined hills, sculpted like teardrops pointing downstream, evidence of water moving fast enough to rearrange entire landscapes. Another sign is sediment, when a proglacial lake drains suspended silt and clay surge out and then settle in quieter water, forming distinct layers. Offshore from likely outflow points, cores from ocean floors and large lakes sometimes show sudden, thick packages of fine material, lighter in colour, with grain sizes and mineral signatures that match the glacial basins upstream. Radiocarbon dates on microfossils within and above those layers give ballpark ages for when the floodwaters arrived and when conditions returned to normal. On land in old lake basins that once held Agassiz and its cousins, you can sometimes see ancient shorelines etched into hillsides, beach ridges and wave-cut terraces marching up slopes in steps. Their elevations record past lake levels, where those ridges end abruptly or where they show signs of rapid fall. Researchers see hints of sudden lowering events, times when the water found a new way out. People were living in and around these shifting waters. By the time the last great drainage pulses occurred, North America was home to diverse hunter-gatherer groups. Some followed big game across open plains. Others exploited rivers, wetlands and forests. For them, a lake like Agassiz was not an abstract reservoir. It was a horizon, a source of fish and waterfowl, a barrier difficult to cross, and a climate engine that influenced local weather. When shorelines moved tens of kilometres over a few generations, familiar campsites might end up stranded far from the water or submerged beneath it. A low pass used for seasonal migrations could suddenly become a spillway, dangerous during certain weeks of the year, then carved so deeply by floodwater that it no longer offered an easy crossing. Drainage shifts could reroute whole river systems, turning a known travel corridor into a maze of marshes and isolated basins. Game animals responded too. Herds that once skirted lake margins might find new grazing grounds on freshly exposed land as levels fell, or be blocked by newly formed inlets and channels when levels rose. Waterfowl nesting grounds could appear and vanish in a matter of years. For human groups keyed into these rhythms, the changes meant adjusting hunting strategies, moving seasonal rounds, sometimes abandoning routes that had been used for generations. At the same time, meltwater landscapes created refuge zones. Islands left behind as water receded, peninsulas projecting into big lakes, and high ground overlooking spillways could offer rich, defensible patches of habitat. Edges where forest met open shore, where river met lake, where fresh water bled into newly formed wetlands. These were places where fish, birds and mammals concentrated, for people flexible enough to follow the water, to shift from tracking mammoth to netting fish or trapping beaver. The fringes of Agassiz and the other proglacial lakes may have been opportunities as much as threats. From a distance traced on a map, the history of North American meltwater can look like a sequence of arrows and colour changes. Ice retreats, lakes grow and shrink, floods pour south, east or north, But on the ground, for the families walking those shores, the transformation was lived as a series of local surprises. A river that suddenly ran too high, a sandbar that vanished after a great storm, a distant crashing at night when part of an ice dam gave way. As with Doggerland, those changes did not pass unnoticed. They would have inspired cautionary tales about treacherous crossings, stories about times when the big water ran low or when it broke through and swept the valley. Later, when the ice was finally gone and the giant lakes had settled into the outlines of the modern Great Lakes and river systems, the memory of a landscape in motion could linger in oral traditions, compressed, simplified, but still carrying a sense that the waters had once been larger, more unpredictable, and dangerously alive. As the ice shrank and the great proglacial lakes found their escape routes, something else was happening all over the planet. The world was getting wetter and wilder, not in the sense that it rained all the time, everywhere, but in the way water moved through the air and across the ground. A warmer atmosphere can hold more moisture. That means when conditions line up, the sky doesn't just give a gentle drizzle, it can dump staggering amounts of water in a short time. Storm systems tap into ocean heat and moisture like never before, carrying it deep into continents. Where cold fronts meet that warm, wet air, you get intense downpours, swollen rivers, and floods that rework whole valleys. Hydrologists sometimes describe this as an intensified hydrological cycle. In practice, it means extremes. Longer dry spells in some seasons, then heavier rains when they do come. Snowlines shifting uphill, but mountain storms dropping torrents that rush down into foothills and plains. For rivers, especially those fed by monsoons or melt from small shrinking glaciers, the late glacial and early Holocene were not a gentle glide into stability. They were a period of experiment. Rivers, unlike lakes, rarely sit still. Left to their own devices, they wander. They erode one bank, deposit sand on the other, loop outward in great curves, then cut through the neck of a meander and leave an oxbow lake behind. Over centuries, a mature river can shift its channel sideways by kilometres without ever leaving its floodplain. But under the kind of stress that came with post-ice age warming heavier, rains, rapid snowmelt, sudden pulses of sediment from freshly exposed hillsides, some rivers did more than wander. They jumped. Geomorphologists call this a volscian, a river suddenly abandoning its old course to carve a new one, often during a flood. Picture a swollen channel rising higher and higher until it overtops a low point in its levee, then cutting a shortcut across the floodplain. In a matter of days or weeks, what had been a minor side channel becomes the main flow. The old river bends, painstakingly sculpted over generations, are left as backwaters and stagnant lakes. In big lowland basins, avulsions can create entire new deltas. Nowhere shows this more clearly than the world's large river mouths. The Nile, the Ganges Brahmaputra, the Mississippi, the Tigris Euphrates, all have built deltas not as single, simple fans, but as overlapping lobes. Over time, as sediment clogs one set of distributary channels, the river will punch a new route to the sea, beginning a fresh lobe while the old one slowly subsides. On a geological map, you see patchworks of abandoned and active channels, like a river trying out different ways to reach the ocean. Farther upstream, where gradients are steeper and sediment loads higher, rivers often braid instead of meandering. Braided rivers split into multiple intertwining channels divided by bars of gravel and sand. In flood, those bars shift, channels merge or vanish, new ones open. From the ground, for anyone trying to cross, a braided river can be a shifting maze, never quite the same from one season to the next. As glaciers retreated in mountain valleys from the Andes to the Himalayas, meltwater plus loose glacial debris encouraged precisely this kind of behaviour. Into this restless world came people who had learned, through long hardship, to follow water. For small groups of hunter-gatherers, rivers were irresistible. They offered far more than a place to drink. Floodplains concentrated resources, fish in the deeper pools, birds and eggs in the reeds, game drawn to browse the lush vegetation that flourished on regularly renewed soils. River edges produced edible plants, tubers, and later, wild grains in quantities rarely matched in the drier uplands. Travel was easier too. A canoe or simple raft could carry more weight with less effort than a person on foot. Even without boats, a river valley often provided the gentlest route through rough terrain, a natural corridor linking distant regions. So early camps clustered along banks, on levees, on slight rises above seasonal high water. The risk was obvious. When the river rose too high or too fast, those same camps could be swept away. Hearths, stored food, and sometimes people themselves could vanish in a night of roaring water and breaking trees. Yet the pull of the river was strong enough that, again and again, groups rebuilt nearby. The benefits outweighed the danger, until the danger itself became part of the story. Floods were not only destructive, they were creative. Every time a river overflowed its banks and spread out across its floodplain, it carried with it a suspension of fine particles, silt, clay, organic bits torn from upstream soils. As the water slowed over flat ground, that load settled out, layering the plain with fresh, fertile sediment. Over dozens of generations, the same patch of land might be buried under meters of flood deposits. Old camp layers, hearths and bones could end up sealed beneath new topsoil. To someone coming back season after season, the land might seem to heal itself. Scoured patches turning rich and green again, new sandbars appearing where last year's had been taken. Floods also reshaped what the river offered. A major avulsion could strand fish-rich backwaters where the main current once flowed. Braided reaches might open new gravel bars ideal for certain plants, or cut off chunks of forest that became islands, refuges for animals and people alike. A channel shifting a little closer could shorten travel time to a seasonal hunting ground. Shifting away could make that same path longer and more dangerous. In this sense, rivers didn't just supply water and food. They wrote, erased, and rewrote the map of how people moved, traded, and met one another. Imagine you belong to a group that has lived along one of these great dynamic rivers for as long as anyone remembers. Your grandparents told you about the year of the high water, when the river climbed higher than the tallest man could reach and carried whole trees past camp. Your parents remember the season when the channel cut a new bend and turned a familiar ford into a deep, swirling pool. You have your own stories of sudden ice jams breaking in spring, of thunderheads massing upriver, and the water rising, quietly at first, then faster. Now picture neighbouring groups up and down the valley, each with their own accounts. A disastrous flood on an upstream tributary that sent rafts of debris crashing past your camp might be remembered upriver as a storm that erased entire villages. Farther downstream it might be known only as the year the fish came in unusual numbers afterward. Over centuries, these separate episodes can blur together in memory. Different floods at different times, stitched into a single tale of a river that once rose higher than the hills, or that abandoned its path and took a whole people with it. In a warming, water-rich world, these kinds of river disasters were not rare events. Monsoon failures and bursts, snowmelt surges, landslide dams that burst suddenly, channels that jumped their banks. Each valley had its own history of near misses and catastrophes. When later generations, living in more stable times, told stories about a great flood, they may not have been recalling one unique global cataclysm. They may have been compressing a long, complicated relationship with unpredictable rivers into a single powerful narrative. Under the right conditions, many rivers over many lifetimes could together create the memory of one overwhelming flood. And in a few places, along a few particularly important rivers, those memories would intersect with something else that was changing. not just how people moved and camped, but how they grew their food and built their settlements. When people along those restless rivers began to do more than just gather what they found, the world quietly crossed another threshold. Today, when we hear birth of farming, we tend to picture a single invention, someone planting a seed on purpose for the first time, watching it grow and deciding to settle down. The reality looks messier, slower, and more regional. But there is one broad pattern most archaeologists agree on. Some of the earliest clear steps towards systematic cultivation took place in and around a band of land that curls from the eastern Mediterranean through northern Mesopotamia and down toward the Persian Gulf. Later writers would call it the Fertile Crescent. In this arc of hills and valleys, rivers like the Euphrates, Tigris and Jordan, and smaller streams feeding them, ran through a patchwork of environments. Upland slopes with wild stands of wheat and barley, lowland floodplains that grew thick with reeds and edible plants after seasonal inundations, steppe zones where gazelle and wild cattle roamed. From roughly 14,000 to 10,000 years ago, groups we sometimes call Natufians and their neighbours were camping, and then more than camping, in these landscapes. The climate here was changing too. After the violent swings of the last ice age, the early Holocene brought something unusual, relative stability. Not perfect, not unbroken, but in many regions the wild lurches of temperature and rainfall softened into gentler oscillations. For people who had learned to track seasons with exquisite precision, that stability meant predictability. Plants tended to flower at more consistent times. Rains, while still erratic from year to year, fell within narrower bounds. Rivers still flooded, but in patterns that could, to some extent, be anticipated. In that kind of world, a subtle shift in behaviour becomes possible. Imagine your group has returned to the same valley for generations because the wild barley comes in thick there every spring. Over time, you learn which patches produce best. You start clearing away the most aggressive weeds with digging sticks, scattering a few heads of grain in disturbed soil as you process your harvest. You notice that if you leave certain stands alone until the seeds are heavy and dry, next year's growth looks better in that particular patch. At first, this isn't farming in any modern sense. It's encouragement, tending wild plants, not owning fields. But it already depends on two things that rivers and a calmer climate make possible: confidence that you can come back to the same place next season, and confidence that the seasons themselves will behave roughly as expected. Storage follows close behind. If you can trust that next year will bring something like this year, it begins to make sense to put aside surplus in a more deliberate way. Pit caches dug into dry ground, baskets hung above damp soil. Later, clay bins built against house walls. Grains and nuts can bridge not just the lean months of a single year, but the gap between one harvest and the next. In a world where rainfall isn't constantly changing the rules, those investments pay off more often than they fail. Floods fit uneasily into this new equation. On one hand, every person who has lived beside a river learns that floods destroy. A sudden rise can flatten stands of ripening grain, rot stored seeds, and undermine the walls of early houses built out of mud and timber. A channel that jumps during an avulsion can turn what was the prime patch of barley into a gravel shoal overnight. For communities that had begun to count on specific fields, these events weren't just inconvenient. They threatened the whole year's security. On the other hand, those same floods brought gifts. A gentle overbank flood, spreading out over a low plain and retreating without too much turbulence, leaves behind a thin mantle of silt and organic matter. In the Nile Valley in Mesopotamia, and in smaller river basins all around the Fertile Crescent, such floods renewed soils that might otherwise have been exhausted by repeated harvesting. Plots just high enough to escape the worst scouring, but low enough to catch fine sediments, could produce abundantly with relatively little amendment. For early cultivators, the best land was often the land regularly kissed, but not drowned by high water. So floods acted as both threat and promise. They could erase labour in a single bad year, yet they were also part of what made floodplains so attractive to begin with. This tension raises a question historians and archaeologists still debate. Did the danger of floods push people to cluster in more permanent, defended settlements, or did it encourage mobility, having backup camps and fields elsewhere, so no single disaster could wipe you out? The evidence suggests something in between. In some parts of the Fertile Crescent, we see increasingly substantial villages, stone foundations, semi-subterranean houses, communal structures appearing in landscapes where water and arable land are tightly focused. Here, predicting and managing floods may have been part of what held people in place. A community that knew where the river usually spread, how high the water tended to rise, and where to build on slightly raised ground could reap the benefits while minimizing the worst losses. Shared storage facilities and collective labour on small canals or diversion channels may have made staying put more viable than moving. Elsewhere, especially in more marginal zones, mobility seems to have remained important even as cultivation intensified. Groups might plant in several microenvironments, one near the main river, another on a side wadi, a third in upland lowest soils, and shift their residence depending on which areas fared better in a given year. In these cases, floods that ruined one set of plots could be balanced by success in another. Settlement consolidation did not necessarily mean a single immovable town, but rather networks of sites tied together by kinship, storage, and shared knowledge of water. It's tempting to imagine a single driving force behind the rise of agriculture, a great flood that forced innovation, or a perfectly stable climate that allowed it. The archaeological record, however, points to a web of interacting factors. Climate stability mattered, but so did the long, patient familiarity foragers had developed with particular plants. Floodplain fertility mattered, but so did social ties that allowed risk-sharing. Population pressures, the appeal of surplus, symbolic meanings attached to certain grains or animals, all likely played roles. Within that web, floods were one thread among many. They shaped where early farmers chose to live, how they managed soil, and how they thought about security and loss. They made some valleys both dangerous and irresistible, and they ensured that from the very beginning the story of fields and villages could never be told without also telling the story of water rising where it was not supposed to go. On a low rise in southeastern Turkey, far from any great river, there is a hill that isn't quite what it seems. For a long time, villagers ploughed its flanks and hauled away stones, thinking it was just another knoll. Underneath lay something older than pottery, older than metal, older than the villages we usually point to as the start of civilization. We call it Göbekli Tepe. Radiocarbon dates place its earliest levels right around a crucial threshold, roughly 11,600 years ago, at the very end of the Younger Dryas, that strange cold relapse after the last ice age. In climate records from ice cores and lake sediments, you see the line, temperatures jerking up, rainfall patterns shifting, glaciers finally retreating in earnest. In the ground at Göbekli Tepe, you see something else, people responding with stone and story. The site is not a town in any conventional sense. There are no clear houses from the earliest phases, no neat streets, no permanent fields stretching away in all directions. Instead, archaeologists have uncovered a series of circular and oval enclosures, each framed by massive T-shaped limestone pillars. Some weigh many tons. Many are carved with animals, foxes, wild boar, birds, snakes, big cats, abstract symbols we do not yet know how to read. Whoever built this was not simply scratching out a living. Yet the bones and plant remains scattered in the surrounding layers tell a familiar story. These were still overwhelmingly hunters and gatherers. They harvested wild cereals, wheat and barley cousins, growing on nearby hill slopes. They hunted gazelle, aurochs, onager, game birds. There are hints of early management, more intensive exploitation of certain plants, maybe some tending of stands, but not the full agricultural package that comes later. Göbekli Tepe then sits in an in-between world. Socially, it looks like something we usually associate with much later village societies. Large-scale cooperation, labour marshalled for projects far beyond the needs of a single family. Shared spaces that may have been used for rituals, feasts, or seasonal gatherings. Economically, it still belongs mostly to the foraging era. That combination is part of what makes the site so unsettling. It suggests that monumental architecture, organised religion, and complex social hierarchies did not have to wait for full-time farming. Under the right pressures and with the right opportunities, people could experiment with large, symbol-rich meeting places while still living in relatively mobile, small groups. The environmental backdrop to these experiments was anything but calm. As the Younger Dryas ended, the hills around Göbekli Tepe saw their own version of the Great Transition. Pollen from nearby cores shows shrub and woodland species shifting, steppe grasses rearranging themselves as cooler, drier conditions gave way to warmer, somewhat wetter ones. Some animals expanded their ranges, others contracted. For people who depended directly on wild herds and wild stands of grain, this meant that the old maps in their heads were going out of date. Patches that had produced reliable harvests might suddenly fail. Migration routes used by gazelle for generations could bend or break. Springs that once trickled through the dry season might stop altogether, while others emerged in new places. In such a landscape, knowledge became both more precious and more uncertain. A group that knew where the new stands of cereals were thickest, or where game now congregated, had a crucial edge. A group that clung too tightly to yesterday's patterns risked hunger. Some researchers think Göbekli Tepe was one answer to that uncertainty. Not a temple in the modern sense, and not simply a village, but a meeting node. A place where scattered bands might converge at particular times of year to share food, exchange obsidian and other raw materials, arrange marriages, tell origin stories, and perhaps quietly trade information about a changing world. The effort required to carve and raise those pillars would have demanded coordination across many people and probably many groups. To work side by side on a structure that would outlast any one lifetime, you have to imagine yourselves as part of something larger than the daily hunt. The sky above them was changing too. As the ice retreated and sea levels rose, the rotation and wobble of the Earth carried the familiar constellations slowly along their precessional paths. Over centuries, the timing of star risings and settings drifted against the seasons. For people who had long used the heavens as a calendar, tracking when certain stars appeared at dawn to mark migrations or ripening times, these slow shifts might have been deeply disorienting. This is where Göbekli Tepe has attracted some of its most speculative interpretations. Some authors have proposed that the pillars encode star patterns, that specific animal figures correspond to constellations, that the enclosures track precession or commemorate a traumatic celestial event, a comet impact, an outburst in the meteor streams sometimes linked controversially to the Younger Dryas, cooling, and the great meltwater pulses. Others draw lines between the site's dates and abrupt climate oscillations, suggesting that rituals there were responses to remembered catastrophe, floods, fires, or the day the sky changed. The evidence for these specific claims is debated. Many archaeologists caution that the carvings may not map neatly onto our constellations, that alignments can be found by chance in almost any complex structure, and that oral memories of events 1,000 or more years in the past are notoriously hard to trace. For now, Göbekli Tepe's precise meanings remain opaque. What we can say with more confidence is narrower, but still remarkable. Around the time the Younger Dryas ended, and the climate lurched toward warmer, more stable Holocene conditions. People in this corner of the Fertile Crescent invested enormous energy in a place that was not a home and not yet a city. They hauled stones, carved animals, hosted feasts, and then, intriguingly, buried their own enclosures under deliberate mounds of debris, only to build new ones nearby. It looks like a cycle of construction, use and closure, for reasons we can only guess at. In that sense, Göbekli Tepe is less a smoking gun for a single great flood or a single comet, and more a lens on a broader pattern. When environments shift quickly, when rains come at odd times, when familiar stars no longer herald the old seasons, when game and grain move on, human societies often respond not just with new tools, but with new kinds of gatherings, new stories, new architectures of meaning. This hill of buried pillars shows that, at the dawn of the Holocene, upheaval and innovation walked together. Before fields were fully tamed and cities rose on river plains, people were already experimenting with being more than scattered bands. They were building places meant to bring many lives into one shared story, a story that in later ages would often be told in the language of floods and foundations, endings and beginnings, remembered under the same changing sky. If you stand at Göbekli Tepe in your mind for a moment longer, in that in-between world of hunters, half-tended grains and shifting skies, another question rises quietly out of the stone. How does any of this get remembered? Not as pollen grains in a core or isotopes in an ice sheet, but as something a grandmother can tell a child, as a story that still has enough force, thousands of years later, to bend how people see the world. Human beings don't carry climate graphs in their heads. They carry narratives. In small oral societies, memory lives in voices and bodies. A story that matters has to be told often enough to survive the deaths of those who first experienced it. Around fires, on long walks, during rituals at places like Göbekli Tepe, people pass on what they think is important, where the good springs are, which plants heal and which kill, who betrayed whom 3 generations ago. But raw events are messy. They don't fit easily into the attention span of a tired listener at the end of a long day. So memory compresses. Instead of 100 years of unpredictable rains and scattered crop failures, you get, there was a time when the seasons went mad. Instead of describing a tangle of meltwater pulses, shoreline shifts and slowly drowning marshes, you get, once the waters rose, details that don't serve the lesson fall away. The rest gets sharpened. This is one of the basic mechanisms of cultural memory. Oral tradition trims and polishes over time. Stories are shortened, repeated, made more rhythmic so they're easy to recite. They pick up symbolic weight. A dangerous, unpredictable river that took many lives may become, in story, a single, overwhelming flood. A long, grinding period of scarcity may contract into the Great Famine or the winter that never ended. When people start carving animals on pillars, or painting figures on cave walls, or arranging stones in deliberate patterns, they're doing something similar in another medium. They're turning complicated, half-remembered experiences into symbols you can point to. A vulture might stand for death and sky and the dangerous boundary between them. A snake might carry meanings about rivers, the underworld, or threats that come suddenly from below. A boat scratched on rock in one generation can remind the next not just that boats exist, but that once, when the world nearly drowned, it was the boat builders who saved us. Floods in particular make sticky stories. Part of it is simple psychology. Sudden events that threaten your life are far more likely to lodge in memory than slow changes that unfold over many years. A shoreline that creeps inland by a few centimetres each season is easy to ignore. A storm that rips houses away in a single night is not. Water has a special place in that drama. We need it desperately. It sustains fields, animals and people. But when it arrives in the wrong form, too much, too fast, in the wrong place, it can erase whole landscapes. A village swallowed by fire leaves char and ruins. A village swallowed by water can, from a survivor's eye, simply vanish. Floods also lend themselves to moral framing. If a community survives a near catastrophe, it's hard not to ask why. Did we anger something? Were we spared for a reason? In answering those questions, people tend to weave values into the narrative. Those who ignored warnings, who refused to help, who hoarded food, perhaps they are remembered as the ones swept away. Those who listened, who shared, who showed courage, perhaps they alone found the high ground, or entered the boat over generations. That moral lesson can become more important than the original meteorology. A freak storm, a broken ice dam, a tsunami triggered far away may fade into the background, while the story crystallizes around obedience, justice, mercy, or the dangers of arrogance. The flood becomes not just something that happened, but something that happens when people behave a certain way. As the centuries pass, details mutate. A local river that once tore through a valley can expand in memory until it is the sea. Hills above a floodplain can grow into the only mountains left. A few terrible years may stretch into an age when the sun barely shone. People who fled along a particular route may come to be described as the only family spared, because tracking 1,000 scattered survivors is harder and less satisfying than following one line. As groups migrate, they carry these stories with them, and the tales adapt to new geographies. A people who once lived near a lake that overspilled its banks might relocate to a coastline and begin setting the same ancestral flood in motion across an open ocean. The core pattern stays: waters rising, lives in peril, some chosen or clever or lucky remnants surviving. The scenery updates itself to match the audience's world. Scholars who compare flood traditions across regions look for what lies under those shifting surfaces. They pay attention to structure. Is there a warning before the waters come? Is survival achieved by climbing, by boating, by retreating to a particular sanctuary? Does the story emphasize moral failings, ritual failures, simple bad luck, or impersonal cycles of nature? They compare motifs that are hard to explain by simple coincidence. A bird sent out 3 times to test for dry land, a boat grounded on a specific kind of mountain, survivors preserving seeds or animals in some kind of container. When such details appear in multiple traditions within a connected cultural sphere, it can hint at shared ancestry, the way languages can be traced back to older roots. They also watch for how myths line up with independent evidence. Does a cluster of flood stories in one region coincide in time with geological traces of a major tsunami or lake outburst? Do oral histories of the day the sea came in map onto drowned river valleys discovered by marine archaeology? Sometimes the answer seems to be yes. Sometimes the fit is loose. Sometimes there's no clear match at all. In all of this, there's a danger that hovers over every dramatic tale, the temptation to assume that every myth must point to one single spectacular event. A global deluge that wiped the slate clean. One comet, one impact, one day when everything changed and every culture on Earth somehow remembered the same moment. It's an alluring idea. It offers simplicity where the past is usually messy. But the real world of ice, oceans, and human communities is rarely so neat. Different valleys flood at different times. Coasts are reshaped by many storms, many surges, many centuries of sea level rise. People live through dozens of lesser disasters for every truly world-shaking one. What we can say is more modest and, in a quieter way, more powerful. Human beings are expert at turning danger into meaning. We take the sharp edges of catastrophe, floods, famines, fires, plagues, and sand them down into stories that teach our children how to live, who to trust, what to fear, and what to hope for when the sky darkens. By the time scribes in the ancient Near East began pressing reeds into clay, some of those stories had already been travelling, changing shape for thousands of years. In the next stretch of our journey, we'll follow a few of them into the written record, into the great flood traditions along the Tigris and Euphrates, and see how water, memory and myth came together on the river plains where the first cities rose. When those first stories step out of the firelight and onto clay, one of the loudest voices belongs to a man named Atrahasis. His tale survives on tablets from Mesopotamia, copied and recopied by scribes over many centuries. By the time we meet him, the world already has cities and kings, canals and brick walls. But the logic of the story feels older than all of that. In the Atrahasis epic, the gods have a problem. Humans, who were originally created to do the hard work, digging ditches, tending fields, maintaining the divine estate, have become too noisy. Their numbers have grown, their clamour disturbs the chief god's sleep. It's a very human complaint projected upwards. The neighbours are unbearable, and someone powerful is about to lose their temper. The first solution isn't a flood. It's population control, plagues, droughts, famine. A series of measures meant to thin people out. Each time the wise man Atrahasis, with help from a sympathetic god, finds a way to ease the suffering, to teach his people how to survive. Each time the noise returns. Finally the decision is made: wipe the slate clean. A great flood will drown everything. The gods swear an oath of secrecy, but one of them breaks ranks. He whispers the plan to Atrahasis through the wall of his house, in a kind of legal loophole. Build a boat, he says. Load it with your family, with animals, with seeds. Pretend you are moving to live with another god. When the waters come, do not look back. The storm that follows is not gentle. For 7 days and nights, winds and waters rage. Even the gods are terrified at what they've unleashed. They cower, hungry and regretful, as humanity disappears beneath the waves. When the boat finally grounds on a mountain, Atrahasis releases birds to test whether the flood is receding. A dove, a swallow, a raven sent out, recalled, watched for signs of dry land. When he disembarks, he offers a sacrifice. The hungry gods gather like flies over the smoke, suddenly aware that in destroying their labour force, they've also destroyed the source of their offerings. A compromise is reached. Humans will go on, but with new limits, shorter lifespans, infant mortality, priestesses who do not bear children. The noise must never get so bad again. Many centuries later, another epic in the same cultural world takes up the flood again and reshapes it. In the Epic of Gilgamesh, the great king of Uruk is on a quest for immortality. Along the way, he meets a mysterious figure named Utnapishtim, a man who has done what no one else has, survived the flood and been granted a kind of eternal life. Utnapishtim's story is, in many ways, Atrahasis all over again. Secret warning from a god. Instructions to build a huge boat. The puzzlement of neighbours who see a ship rising in a dry place. A furious storm, a boat sealed like an egg, a mountain where the vessel comes to rest. Birds sent out 3 times. A sacrifice that draws the gods who swear not to repeat such a total destruction. But the framing has shifted. In Atrahasis, the flood is about population, labour, and cosmic housekeeping. In Gilgamesh, the flood is about the limits of human life. The same catastrophe becomes a lesson for a king. Even if you survive the worst disaster imaginable, you still cannot escape death forever. Gilgamesh returns home with wisdom rather than immortality. If you've grown up with the Hebrew Bible, it's hard not to hear other echoes. A divine decision to bring a flood because human behaviour has gone wrong. A single righteous man chosen to build an ark. Instructions about animals 2 by 2 or in 7s. Rain and storm for a set period. Waters covering even the high places. A boat resting on a mountain. Birds sent out, one after another, until a dove does not return. A sacrifice afterward, and a promise not just about water, but about how or whether such judgment will recur. In the biblical version, the theology has turned a different way. There is one God, not many. The concern is less the volume of human noise than the violence and corruption of human societies. The post-flood covenant is framed not as a compromise between quarrelling deities, but as a solemn decision never again to destroy all life in that way. Historians and literary scholars see a family resemblance here, not a carbon copy. Mesopotamia was a world of rivers, the Tigris and Euphrates, with their unpredictable shifts and seasonal surges. Low, flat plains where a breached levee or an unusually heavy storm could send broad sheets of water racing across the land. Irrigation canals that brought life when they worked and devastation when they failed. In such a setting, it doesn't take a global ocean to feel as if the world itself is drowning. A city-wide or region-wide flood can be absolute from the point of view of those who experience it. These stories probably sit on top of layers of experience like that. Frequent river floods, occasional catastrophic ones, storm surges driven far inland by severe weather in the Persian Gulf. Over longer spans, the slow drowning of low coasts as sea level continued its post-glacial rise. Each event leaving traces in memory, which over generations are braided into a single archetypal flood. What changes with writing is not just preservation, but stability. Once a scribe has pressed the flood into clay, fixed the sequence of birds, the dimensions of the boat, the speeches of the gods, that version becomes an anchor. It can still be edited, adapted, translated into new languages and religious frameworks. But it resists the kind of fluid mutation that oral tales undergo with every telling. Literacy lets myths travel farther than their original communities. A story composed in one city can be copied in another, taught in scribal schools, woven into royal inscriptions and temple rituals. When later authors in neighbouring cultures sit down to write their own accounts of beginnings and endings, these written traditions are part of the mental furniture. It's tempting to treat such texts as if they were ancient news reports, chronicles of a single enormous flood we could, with enough digging, match to a specific year or layer of sediment. But myth doesn't work that way. The Near Eastern flood stories carry weather and water, yes, but they also carry arguments about power, justice, obedience, the proper place of kings and commoners. They are ways of thinking through what happens when human societies grow, clash with their environment, and suffer the consequences. In that sense, whether there was one great deluge or many smaller ones is only part of the picture. These narratives are evidence that people living along those restless rivers were trying to make sense of a world where the line between security and disaster could be crossed in a single season. They took the memory of churning brown water and toppled walls and turned it into something that could answer deeper questions. Why are we here? Why do we die? What do the powers above us expect? And once those questions are written down in flood form on clay, they don't stay on the river plains. They begin to drift outward, carried by traders, exiles, missionaries and conquerors, reshaping themselves as they go. In the next part of our journey, we'll step back from the tablets and ask a harder question. If some ancient flood really did loom unusually large in human memory, what would the evidence for that look like, thousands of years later, under the mud and the sea? To answer that, we have to leave the world of kings and gods and step into the quieter world of clocks. Not clocks with gears and hands, but clocks made of carbon, mud, ash, and trapped electrons. When archaeologists talk about dating a site, they're really talking about lining up different kinds of clocks, each with its own quirks, and seeing whether they tell the same story. One of the most famous is radiocarbon. All living things take in a tiny amount of radioactive carbon-14 while they're alive. When they die, that intake stops, and the carbon-14 in their bodies starts to decay at a predictable rate. By measuring how much is left in a piece of charcoal, a bone, a seed, we can estimate how long ago something died. But the radiocarbon clock doesn't tick perfectly. The amount of carbon-14 in the atmosphere has wobbled over time, thanks to changes in Earth's magnetic field, solar activity, and even big volcanic eruptions. If you don't correct for that, your dates come out skewed. So scientists compare radiocarbon ages with other clocks that are more regular, especially tree rings, those thin alternating bands laid down year by year in old trunks and timbers. By matching radiocarbon ages to trees of known age, we can build calibration curves that say, in effect, when the lab machine says this bone is 10,000 radiocarbon years old, in calendar years it's closer to this particular date. For the last 15,000 years or so, those curves are getting very precise. That's the first tool you'd want if you were hunting for a real, unusually large flood. Another kind of clock sits at the bottom of lakes. In some cold, quiet basins, sediment settles in thin annual layers, light in summer, dark in winter. These are called varves. Count them like tree rings, and you have a year-by-year account of what washed into the water. A sudden flood shows up as a thick, coarse layer dropped all at once, a pulse of sand and silt interrupting the gentle rhythm of fine mud. Spread your cores around a region, several lakes in the same watershed, and you can see whether those flood layers line up. Do they all spike in the same few years? Or do they show many separate events spread over centuries? Volcanoes give us another marker. When a big eruption happens, it can scatter a dusting of ash, tephra, over enormous distances. That ash has a chemical fingerprint. Find the same distinctive band of tephra in different cores, and you have a kind of timestamp, a layer you know formed in the same short window everywhere it appears. Anything above that layer is younger, anything below is older. If a legendary flood really followed, or preceded, a known eruption, this is one way we could check. And then there's a stranger clock, hidden in grains of sand. When sediments are buried away from sunlight, electrons slowly accumulate in crystal defects inside minerals like quartz and feldspar. Expose those grains to light, and the clock resets to zero. This is the basis of optically stimulated luminescence, OSL. Dig up a sample, carefully shield it from light, measure how many electrons are stored, and you can estimate when those grains last saw the sun. It's especially useful for dating ancient shorelines, dunes and flood deposits where no bone or wood survives. Put all of these together, and you get a toolkit for asking very specific questions. If there was a sudden, catastrophic flood in a given region, what would it leave behind? In a lake core, you'd expect a sharp, chaotic layer, coarse material dumped rapidly, maybe mixed with bits of shell or organic debris torn from the shore. The grains in that layer might come from farther up the watershed than usual, telling you that fast, powerful water was ripping through the landscape. If the flood was salt water surging inland, you might see a brief invasion of marine microfossils, tiny foraminifera or diatoms that normally live in the sea, trapped in what is otherwise a freshwater record. On the coast itself, a rapid flood or storm surge can carve and pile in characteristic ways. You might find old dunes sliced cleanly, river mouths abruptly shifted, large boulders deposited in places only extremely strong waves could have reached. Ancient beach ridges, the low sandy bars that mark former shorelines, might show a sudden step, a jump in position that doesn't fit with slow, steady sea level rise. A truly extraordinary marine flood, the kind that might inspire a civilization-wide story, would likely leave a belt of such evidence. Abnormal sand sheets in low-lying plains, overwashed deposits pushed far inland, drowned soils and forests sealed under new marine mud. And beneath today's waves, there is more to look for. When sea levels were lower, people lived on coasts that are now underwater. If those communities were suddenly flooded by rising seas or storm-driven surges, their remains might still lie on the continental shelves, in water that today is tens of meters deep. Underwater archaeologists search for those lost landscapes in several ways. They map the seabed with sonar, looking for ancient river channels, terraces and shoreline features, cliffs, beach ridges, lagoons, now hidden by water and sediment. They take cores from the seafloor, hoping to hit buried peat layers, root mats, pollen-rich soils that tell of once dry ground. Sometimes they find tree stumps still rooted in place, drowned forests that mark the line where land gave way to sea. In a few places they also find unmistakably human traces, worked flint, hearthstones, pieces of bone with cut marks, all in contexts that show they were left when that spot was still above water. If we were to find a cluster of such drowned sites all along a particular ancient coastline, all abandoned within a very narrow time window, all overlain by flood deposits dated by radiocarbon and OSL to the same decade or two, that would be powerful evidence for a sudden, region-wide inundation. So far, the picture is more complicated. Different regions tell slightly different stories. Some coastlines show relatively smooth drowning over thousands of years, with occasional storm pulses. Others preserve evidence of dramatic local events, glacial lake outbursts, tsunami-like waves from submarine landslides, rapid breaching of natural barriers. These can be devastating on a human scale, but they don't line up neatly into a single global moment. Part of the problem is simply data. Sediments get eroded. Lakes dry up. Cores are expensive to drill. Underwater work is slow and limited to tiny sampling points in a vast seafloor. For many key areas, we just don't yet have the high-resolution records we would need to say, with confidence, exactly what the water was doing in any given century. Then there is regional variability. Sea level did not rise like a perfectly flat bathtub. The melting of ice sheets, the flexing of Earth's crust under shifting weight, local uplift and subsidence, these all make some coasts rise as others sink. Some seas invade quickly while others hardly move. A flood horizon in the Black Sea won't necessarily match a flood horizon in the Persian Gulf, or along the shores of ancient Southeast Asia. On top of that, there is interpretation. Look at a thick sand layer in a core. One researcher might see the signature of a tsunami. Another might argue for a big storm surge or a river flood, or a gradual shift in the channel nearby. Look at a drowned site. Was it abandoned in a panic after a sudden flood, or slowly evacuated over generations as the shoreline crept inland? Small differences in dating and assumptions can tilt the answer either way. That's why controversies persist. Some scholars see patterns that suggest one or two especially severe flooding episodes, perhaps linked to meltwater pulses or regional sea level jumps. Others see a patchwork of many different, only loosely related events, stitched together in memory and story. A cautious synthesis for now goes something like this. In the last 20,000 years, as the great ice sheets melted, sea level rose by more than 100 meters. It did so unevenly, in fits and starts. Along the way, there were many floods, some slow and creeping, others abrupt and violent, reshaping coasts on every continent. People living in low-lying plains and river deltas experienced disasters that, from their vantage point, truly felt like the end of the world. Those local and regional catastrophes are more than enough to seed flood traditions from Mesopotamia to India to China and beyond. The science strongly supports a world of many floods, some very large interacting with vulnerable human communities. What remains unproven is a single global synchronous deluge, drowning every land at once in historical times. If evidence for such a thing exists, it has not yet stepped clearly out of the mud and the cores and the sea floor. What we do see, more and more clearly, is a planet in flux, and humans repeatedly caught at the edge between land and water. As we drift back toward the present, that may be the real lesson of these ancient stories and sediments. Not one moment of judgment, but a long, uneasy dance with rising seas that has never entirely ended. Tonight we've traced only a few steps of that dance. We've watched ice sheets melt and oceans climb, swallowing the wide, gentle shelves where so many early coasts once lay. We've seen glacial lakes held back by walls of ice or earth suddenly give way in breathtaking outbursts, their waters racing across continents and carving scars still visible from space. We've followed river systems pushed beyond their limits, turning from familiar neighbours into roaring brown walls of water that briefly rewrote the shape of valleys and plains. And every so often we've glimpsed the sea itself lurching landward in tsunamis and storm surges, waves born of landslides, earthquakes, or collapsing slopes at the edge of the continental shelf. None of these alone quite matches the universality of the flood stories. But together, over thousands of years, they form a background of rising water and sudden shocks. Not one great flood, perhaps, but many great floods, each one local and terrible, layered into memory, retold, combined, and slowly woven into sagas of a world drowned and made new. In that sense, water really did change humanity. It pushed people off shrinking plains and into new lands. It forced migrations along river corridors and across mountain passes. It nudged small bands into tighter cooperation, new forms of sharing, new ways of marking who belonged and who did not. It encouraged experiments in farming, storage and settlement on slightly higher ground, and it carved the boundaries of some of the first cities. We live with the results. Our ports and deltas sit where ancient shorelines once advanced and retreated. Our myths still speak of judgment and rescue, of arks and rafts and chosen survivors, and out beyond the present coasts, in the quiet dark of continental shelves, there are almost certainly villages, campfires, perhaps even early fields, waiting under layers of mud and sand to be found. Someday, future divers and remote submarines may walk through those drowned homes in beams of artificial light, picking up tools last touched 11 or 12,000 years ago. When they do, some parts of these stories will sharpen. Others may dissolve. New questions will rise, as they always do, with the tide. For now, you can let the uncertainty be a kind of comfort. The world has changed before in ways far larger than any single human lifetime, and yet long chains of people endured, adapted, remembered. You are part of that chain, listening in the dark while the planet goes on breathing around you. If you'd like to hear more history told in this quieter way, you can gently support the channel by liking this video, subscribing, and turning on notifications so you don't miss what comes next. It helps more than you might think, and if you're still awake, I'd love to know where you're listening from. A city on a river, a town by the sea, somewhere inland under clear stars. Leave a comment with your corner of the world, and if you like, how the water sounds where you are. Whenever you're ready, you can let these thoughts drift out with your next exhale and follow your own ancestors into sleep.